Hey, what's up everybody? This video is on how to find the least common multiple, or LCM, of or between two numbers. Now there are two methods to find the least common multiple between two numbers. The first one is listing the multiples of each number or skip counting, and then finding the smallest or least number they have in common. Or what we're going to do today is using prime factorization trees to find the prime numbers involved with the numbers, and then using Venn diagrams to find the least common multiple. So if we're going to be breaking numbers down into prime numbers, first of all, we need to understand what a prime number is. So what is a prime number? A prime number is a number that has only two factors, one in itself, and therefore cannot be simplified. Let's take, for example, the number 3. The only numbers that I can multiply together to get 3 are 3 times 1. And so therefore 3 is a prime number. All right, let's look at 4. Well, what numbers can I multiply together to get 4? I can do 4 times 1, but those are not the only numbers that I can multiply together to get 4. I could also do 2 times 2. And so therefore 4 is not a prime number. All right, it is a composite number. We could talk about that in another video. What about 5? Let's take a look at 5. 5. What numbers can I multiply together to get 5? Or what are the factors of 5? Well, the only factors for 5 are 5 and 1. 5 times 1. All right, and let's look at one more. What about 6? 6. Is 6 a prime number? What numbers can I multiply together to get 6? I can do 6 times 1. Or I can do 3 times 2. And so therefore 6 is not a prime number. Now that we have an understanding of what prime numbers are, here is a list of prime numbers between the numbers 1 and 100. And so on the list, you have 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89, and 97 are all prime numbers. And there are more, but these are the prime numbers that you will deal with when using prime factorization in middle school. Now, what is a prime factorization tree? A prime factorization tree can be used to break down any number down to its prime factors. Or we could use these prime factors to find the least common multiple between two numbers. For example, let's say we wanted to make a prime factorization tree for the number 10. Okay. And so we want to think of two factors that we can multiply together to get 10. All right. And we're not talking about 1 and 10, any numbers other than that number and 1. All right. What two numbers can I multiply together to get 10? I can multiply 5 times 2. 5 times 2. All right. And so now I ask myself, are these prime numbers? And so I can look back at our prime factorization, or our prime numbers chart over here, and I see that 2 is a prime number. It can't be broken down any further. And I see that 5 is a prime number that can't be broken down any further. And so what we have here is a prime number 5, and we have prime number 2. And so we took 10 and we broke it down to its prime factors, 5 and 2. Okay. Now let's say that we want to look at another number. Let's say 6. All right. And we want to do a prime factorization tree for 6. All right. Okay. And so you ask yourself the same question. What two numbers can I multiply together to get 6 other than 1 and 6? Well, I can multiply 2 times 3. Now I need to ask myself, are these numbers prime numbers? Well, if we look back at our prime numbers chart, we see that 2 is a prime number and also 3 is a prime number. I can't break those numbers down any further. And so these are prime numbers. Okay. We'll do another example, and then I'll go into showing you how we use these prime factorization trees to find the least common multiple using a Venn diagram. Let's say I wanted to find the least common multiple between the numbers 24 and 14. All right, 24 and 14. Well, the first thing I would do, like we just did, is do a prime factorization tree for both numbers. That is the start. And so the first question I would ask myself is, what two numbers can I multiply together to get 24? And so there's a few options. I can multiply 12 times 2, or I can multiply 6 times 4, or I can multiply 3 times 8. Any of those will work. And so I'm going to go with 3 times 8. 3 times 8. All right. And so the next question I ask myself is, are either one of these a prime number? And so I look back at my prime factorization, my prime numbers table, and I see that 3 indeed is a prime number. And so I'm going to go ahead and circle that one because that is a prime number. I cannot break 3 down any further. But when I look at 8, is 8 a prime number? I look over at my table. No, 8 is not a prime number. And so therefore I need to continue to break 8 down. And so this is why we call it a tree. It goes, it looks kind of like a fir tree when it's done, or a Christmas tree. All right. And so how can I break down 8? What two factors can I multiply together to get 8? Well, I could do 2 times 4. 2 times 4. And again, I look back at my prime numbers table. I see that 2 is a prime number. And so I'm going to go ahead and circle that prime number. That lets me know that I'm done with that one. Then I look at 4. Is 4 in my table? 4 is not on my table. And so that means I can break 4 down even further. And so that's what I'm going to do. What two numbers can I multiply together to get 4? 2 times 2 equals 4. And as we already know, 2 is a prime number, and so I'm going to go ahead and circle those. All right, 2 times 2. Great, and so now we're going to move over to 14 and do the same thing for 14. All right, what two numbers can I multiply together to get 14? That would be 2 times 7. And so I want to look back at my prime numbers table over here. 2 is a prime number, and 7 is a prime number. And so I'm going to go ahead and circle both of those. And those are my prime factorization trees for those two numbers. And so now this is how we would use the Venn diagram to take these factor trees and you take our prime numbers and figure out what our least common multiple is. Okay. And as you can see in this Venn diagram here, I have 24 on this side. And so that circle represents 24. And then I have 14 on this side. So this circle represents 14. And then I have this middle section here, which is what 24 and 14 have in common. What factor do they have in common? Okay. And so we're going to look at our prime factors here for each number. And we're going to look and see what they have in common. All right. And so here we have a 2 for 24. And I'm just going to draw a line through it. And a 2 for 14. And so they have 1, 2 in common. And so that 1, 2 that they have in common, I'm going to put in the middle of the Venn diagram. Why? Because they share a factor of 2. All right. Do they share anything else? No, they do not. 24 has a 3, another 2, and another 2, and 14 has a 7. And so what we're going to do is we're just going to place those factors in their respective circles. Okay. And so I have a 3, I have a 2, and 2. And then for 14, what I have left after the shared factor of 2 is just the 7. All right. And so now if I wanted to find the least common multiple between these two numbers, I can look at this Venn diagram and I just multiply straight across. All right. All of these numbers I would multiply together to get the least common multiple. And so that would be 3 times 2 times 2 times 2 times 7. All right. 3 times 2 is 6. Oops, 6. And then 2 times 2 is 4. And so we have 6 times 4. 6 times 4 times 7, which is 24 times 7, which equals 168. 168. All right. And so the least common multiple between 24 and 14 would be 168. Let's try another one. Let's find the least common multiple between the numbers 63 and 14. All right. And so using a prime factorization tree for 63, the first question I would ask myself is what two numbers can I multiply together to get 63? And I would do 9 times 7. Well, based on the previous example, I know that 7 is a prime number, and so I'm going to go ahead and circle that. And then we can go ahead and further break down 9. That is not a prime number. What two numbers can I multiply together to get 9? I can do 3 times 3. All right. And I know that 3 and 3 are prime numbers. And so I've broken down 63 to its prime factors. Let's do 14. Again, 14, I can do 7 times 2. And again, based on the previous example, I know that these two are prime numbers. Okay, and so now I would go to my Venn diagram. This first circle represents 63, and the second circle represents 14. And so I'm going to ask myself, what factors do they share? And whatever they share, I'm going to go ahead and put in this middle part of the Venn diagram. All right. And so I can see that they share a factor of 7. And so I'm going to go ahead and put that shared factor in the middle. Okay. Don't make the mistake of putting 2 7s because they share that factor of 7. And so it's only 1 7 in the middle. All right. A good way to remember that is to cross out the factors as you go, the ones that they share. Okay. And so 63, the other remaining factors are 3 and 3. And then for 14, the remaining factor is 2. Now, if I want to find the least common multiple, I take these numbers here that are in the Venn diagram, and I just multiply across. 3 times 3 times 7 times 2. So let's go ahead and do that. 3 times 3 times 7 times 2. All right, 3 times 3 is 9. 9 times 7 times 2. 9 times 7 is 63. And 63 times 2 is 126. And so the least common multiple between 63 and 14 would be 126. Let's try our original problem, the one that we started with the factor trees with, 6 and 10, and see if we can find the least common multiple between those two numbers using this strategy. All right, and so the prime factorization tree for 6, what two numbers can I multiply together to get 6? 3 and 2. As we saw before, we know that both of these are prime numbers. They cannot be broken down any further. And so we go over to 10 and we do the same thing. What two numbers can I multiply together to get 10? 5 times 2. And again, we know that both of these are prime numbers. They cannot be broken down any further. All right. And so what factors do they share? Well, 6 has a factor of 2 and 10 has a factor of 2. And so I'm going to put that factor of 2 in the middle of our Venn diagram. And then what factor does 6 have by itself? That goes here, 3 on the 6 side. And then what factor does 10 have by itself? That's a factor of 5, and that goes on this side. And then again, we just want to multiply across. So 3 times 2 times 5 to find our least common multiple. 3 times 2 times 5. We know that 3 times 2 is 6. And 6 times 5 equals 30. All right. And so the least common multiple between 6 and 10 is 30. As always, if this video helped you in any way, remember to like and subscribe, and I'll see you in the next one.